Hello, Eli and Haley. This is 2-5. They're sticking 2-5 derivatives of trig functions right in between power rule, product rule, quotient rule. We're going to do the chain rule after trig functions, okay? So here we go. We are doing trig functions. The derivative of sine is cosine. The derivative of cosine is negative sine. So it switches, but negative sine when you're taking the derivative of cosine, okay? Now, the product rule, quotient rule, chain rule, all of those things still apply. This guy, we're taking the derivative of x sine of x, which is technically a product. It's technically a product, okay? So we have these two pieces. This one is f, this one is g. All right? Here we go. So we have to do the product rule. Product rule. Okay, the product rule is f prime g plus g prime f. Here we go.
Well, wait. Okay.
F prime g plus g prime f.
It's just gonna stay like this, or is it gonna get worse?
No. It's
Wait,
not
F
terribly
prime
bad.
G plus G
F prime
F.
g plus g prime f. Okay? So, f is x. What's f prime? 1. And then g is sine of x. Okay? G prime, what's the derivative of sine x? Cosine x. And then we have f, which is just x. So f prime g plus g prime f. We write it like that. Let's simplify.
Wait, why is it cosine X? How did it become
Because the derivative of sine x is cosine x.
Does the x
So when we do
go
G
in
prime.
front, or can we go
Yes, we're gonna do that. So this is gonna be sine x plus. I'm gonna put this x in front of the cosine. So x cosine of x. Okay,
Why?
and that's what he is.
Sine.
Okay.
Just like that.
Yep, just like that. That's what we're gonna do.
Why did we have to move this?
Because otherwise it looks.
Otherwise, it looks like cosine xx.
Okay.
Is that it?
So that's it. That's my derivative.
like that.
Yeah, that's not too bad. Okay, so it's just like applying the product rule and the quotient rule and stuff, but it's just with sine and cosine. Okay, now this one's gonna be icky. This is a quotient, and quotient is f prime g minus g prime f
G prime F.
all over g squared. Okay, so my g is 1 plus cosine x. We're gonna take that, and he is squared. Okay, but we're not gonna FOIL him out. We're just gonna leave him. Okay, f prime g minus g prime f. Okay, all right. The top is my f. The bottom is my g. What is it?
Why was Jay
Amber?
so much earlier than everybody else is?
I'm gonna head started running. I'm scared.
Why did it do that?
It's a test.
It's a test of the what?
Of like,
Is this mine or yours?
no,
This is a test of the National
don't know.
Wireless Emergency Alert System. The purpose is to maintain and improve alert
But
and
why
warning
today?
capabilities at the federal, state, local, tribal, territorial levels, and to evaluate the nation's public alert and warning capabilities. No action is
As
required.
most of you know, that was a federal state test for your phone, so kids, you can put them up on the wall, put them back away, and teachers keep teaching class. Thanks.
I really thought that was gonna be more.
I just don't know.
All right.
Why did they do it today?
I don't know.
I thought it was an Amber Alert.
Okay,
Yeah,
g.
that's what I thought.
G
Like,
stays
no,
1 plus cosine x. F stays sine of x. So the only parts that we have to take the derivative of are the two ones that I have blank yet. Okay, so f prime, what's the derivative of sine?
Cosine.
Cosine x. Okay, the derivative of g. So g is the bottom. What's the derivative of 1?
Negative sine.
He goes away. Cosine is negative sine x. Okay, so let's simplify. Let's do a couple things here.
So then the negative
That's just what
becomes
it
a.
is.
Oh boy. Oh boy. Oh boy. Okay, are you ready?
Sine squared x.
Because I keep getting airborne on me every single day. So I
You
get
guys
so
are gonna
every single
love
day.
this.
Cosine
Oh,
x
Mitchell, why
squared.
does this say that?
Don't say it.
Okay, here we go. Ready, set, okay. Cosine times 1 is cosine x. I'm simplifying. What's cosine times cosine?
Cosine squared.
X squared.
Cosine of x squared, but
Cosine
check out, ready for this. Instead of writing as cosine x squared, we write it as cosine squared x. We put the 2 there instead. Okay, that's just the way that we write him. Okay? And then he will be plus, because minus negative, he is sine squared x. Yeah? because there's two of them.
So cosine
All over
x plus
1
cosine
plus cosine x squared.
Plus
Okay.
sine
Is that it?
squared.
Nope, not yet.
Oh, come on.
Almost. Almost. Okay, there he is. All right. You people who didn't take trig, you don't know this yet. But cosine squared plus sine squared is a fancy thing.
Cancellation.
Okay, I have a poster up here. I have a poster up here that said, right there. You can't see him very well. I wish I were a sine squared and you were a cosine squared, so together we could be one.
Yeah, that's right.
You don't know that yet, but you will wait after you take trig. So sine squared plus cosine squared is 1. Okay, so now we have cosine of x plus 1,
Then we can cancel again.
which is the same thing as 1 plus cosine of x, right, on the top,
But can't the cosines of x?
and 1 plus cosine of x squared on the bottom, which means
We have 1 over.
we have 1 left on the top, and we have 1 plus cosine of x just to the first power on the bottom, and that's what he is. Look at that.
Does this go one plus?
How about that? What?
Yeah.
Yeah. So when it comes to simplifying things, you just do the best you can. Okay? Because
My
you
guy
won't
went
know
like,
some of the tricky-do things.
I won't know some of the tricky things.
That's, yeah, it'll be fine. It'll be fine. Okay? All right, good? Okay, moving on. Here are some of the other ones. So tangent, the derivative of tangent is secant squared. I don't know. I don't know. The derivative of secant is secant tangent. Yeah, secant times tangent is the derivative of secant. The derivative of cotangent is negative secant squared, or cosecant squared. And the derivative of cosecant is negative cosecant cotangent. You just plop those in for the derivative. That's it.
How am
But-
I gonna remember this?
You won't. I'll give you a thing. I'll give you a something. A
Will
note
we
card or
ever
something.
be able to remember this?
I remember the sine and cosine, and I know tangent.
In real time.
Okay, I know sine, cosine, and tangent like from memory, but I won't expect you to. Okay, I don't know the other ones. I don't know cotangent. Well, I could if I thought about it real good. Okay, so, all right. They want us to find. Ooh boy, example 3. They want us to find. What does this mean?
Pi divided by
Second
4.
derivative.
The second derivative, and they want us to find at pi over 4. So the second derivative at pi over 4, and they want secant of x. Okay, so we want to find the first derivative. I want f prime of x. What's the first derivative of secant?
At pi divided by 4.
What?
At pi divided by 4.
No, at pi divided by 4. So not yet. We're not going to do the pi over 4 yet until we find the second derivative. Okay, the first derivative is
Secant x tangent.
secant x tangent x. Okay, now problem.
Wait.
Yes, ma'am.
How are we finding the derivative of that?
What?
How
Because
are
this
we
is my
finding the
function.
derivative of that?
So we want to find the second derivative and then plug in pi over 4. This is my original equation. I want to find the second derivative of him.
Okay.
Okay, so there's my first derivative. Now the problem is
Now what do we do with
the second derivative is going to involve the
No. Why do we have, I'm so confused.
product rule. We have a product, right? Secant times tangent.
I
But
thought you said this wasn't gonna get worse.
I mean, it'll get a little worse. It's fine.
She's good at lying.
F prime G.
F prime G plus G prime F.
No, literally.
I'm confused. How do we get the first derivative?
Okay, the first derivative, the derivative of secant is this. The derivative of secant is that. So that's all we
Yeah, but,
do.
like, what happened to the whole? Oh, we're not doing that yet. Okay.
Yeah, we're not doing the pi over 4 thing yet. Just wait. Okay.
Okay, wait. Now we're fine.
So
Okay,
F is secant
So
x.
f prime is the derivative of the f part. The derivative of secant is secant tangent. I didn't put enough room. Secant tangent, secant x, tangent x.
Whoa.
Okay, g is just tangent x. G prime, what's the derivative of tangent?
Tan x.
Secant squared, what's the derivative or just f? F is just secant.
Okay,
Oh,
so I have
heaven's
something.
sakes.
Wait, is it secant or is it secant x?
X.
It's all x. There's all x's on it. Okay, so this guy, if we put him together, he is secant.
Wait.
X.
We need to take a pause.
Yes, ma'am. What's your pause? Oh, for Reese? What is Reese paused on? Can I help you?
G prime.
She's writing them out.
Okay. Okay.
G prime. Secant squared x.
The top left box.
Okay.
Good thing I was
Are we good?
proper. I would be passing out.
All right, this first part, if we simplify him, we have secant and two tangents. So we have secant x and then tangent squared x.
Yeah.
Yeah?
X
Plus, what's that one?
2x plus secant to the third.
To the third.
Secant cubed x.
I don't like saying cubed. I like saying to the third.
Yeah.
Sounds fancy.
It's more dramatic.
Is that it? Now we have to plug in that.
Then we have to do pi over 4.
Do we plug all
Into
that
them.
in for the x?
Pi over 4 goes here. I don't know. We could simplify him a little bit.
How do we do squared in our calculator? We just do 2 of them.
Wait, does the
Yes.
you go in for all of the x's?
Pi over 4 is going to go here. And pi over 4 is going to go here. And pi over 4 is going to go here. Okay, so what I want you to do is you need to make sure your calculator is in
Radian.
radians. Okay, how do you do secant when you don't have a secant button?
Secant minus 1.
No.
No?
How do we know that? How did they
No.
know that we wanted in radians?
I don't remember how to do it.
Because like, we learned that in trig. So anytime you have a pi, you need to be in radians. Do you know how to switch to radians?
What is
We'll help you. It'll be fine.
How do I get to radians? Second mode.
Mode. Yep. Go to mode. Switch to radians. Switch to radians.
And I hit enter.
Okay. And it does it say R in the top corner instead of D? Let me see. Why are you using that calculator? Use the one that I gave you.
my calculator.
No, you want to be in radians. There you go. Now you're in radians. Because it says R80 up there. Okay. All right. So.
hit second quick.
Yep. Sure. Yep. All right. How do we plug in secant?
Second.
Nope. Secant is the same thing as cosecant is the same thing as
Tangent.
cotangent is the same thing as
What?
cotangent is 1 over tangent of x. So when you're typing it into your calculator, you're going to type it in like that. Secant is 1 over
Secant equal or secant.
1 over cosine. Cosecant is 1 over sine of x. Write that down. Write that down. Now we could use the unit circle if we wanted to, but I don't know that that's going to help because they don't know how to read the unit circle. So we'll just use a calculator. It'll be fine.
I know
Can
how to
we
read
please
that.
get a unit circle? I really like the unit circles.
Wait, I do.
I think I saw the worksheet of that one time.
That's
and
fine.
I
We'll
was
do it
like,
on a calculator. It'll be
What?
fine.
It
Kind
looks
of.
Okay.
awful, but it's
It's my
not.
best friend.
It's not that bad. So when we have secant of pi over 4, I'm going to do 1 over cosine of pi over 4. Okay, that's what secant is. Okay, then I'm going to do tangent of pi over 4 squared, because that's what tangent squared of pi over 4 is. I'm going to have it do tangent of pi over 4, and then I'm going to square that number. Okay, plus I'm going to have it do 1 over cosine of pi over 4 again, because that's what secant is. But I'm going to have it take that thing to the third power, and all of this needs to be in radians, and then you will get an answer and you will be done.
This makes me want to not be here.
Okay.
Okay,
So
try practice typing it in.
1 over cosine
And I don't have my calculator because I don't have.
of pi.
Hey, Ellie, do you have your calculator?
I have an answer and I'll show
Where
you.
the heck is
In
the
the middle
pie?
pocket.
Left.
The one right here?
I hate my calculator.
Tangent of
Math.
sine
Why am I in Calc? I don't need to be.
pi
I
over
got 2
4.
square roots of 2.
Tangent.
1 over cosine. So I need to be in.
Plus
Komi, I organized them all
1
nicely.
over
1 over
cosine
cosine.
I know it doesn't matter.
Pi over 4
I did.
4
times tangent of pi over 4
Okay, what did you guys get? Did you get
Squared.
4.24?
plus.
No.
No. What'd you get it?
Well, I got 2 square roots of 2, which is 2.8.
1 over
No, I did something wrong.
cosine of pi
I got like 4.
over 4
Okay, let me try it
To
again.
I might have
third
plugged it in
power.
wrong.
I got 4.24.
Yeah!
Yeah!
Mrs.
Which is
Comer
pi.
I don't think I did it right then.
I'm done.
I had to do the first half and then I had to hit enter and
Okay.
then I had to hit plus.
So, what the heck did we
cosine
just find?
What the heck
Wait,
did I do
wait.
wrong?
The second
I know what I
The
did
second
wrong.
derivative of secant of x at pi over 4 is 4.24. That would be like the acceleration of this function. Not the velocity, not the slope of the tangent line.
Answer.
Second
How do
derivative.
I get that answer?
Or you want to ask me? I just plugged it into the
I also-
calculator.
Mine's just
Wait,
telling
we
me
didn't
Go
error.
back and put parentheses.
Oh. I'm so tired.
I'm confused on what I
Even
got.
with Dr. Pepper, I am like falling asleep.
Okay, that's what I got. Plus
1
Oh.
over cosine. Feels so
Wait, the
disgusting.
first one's not. The first one's not squared though, is it?
Pi.
No, it's not.
Over 4. To the third. Sorry, I fell. 4.24.
Oh, I just got
4.24? Yes, ma'am.
I was too much putting in my calculator.
third power. Oh, you're using a plus sign here. 4.24.
Yeah.
Yeah, I
You
got
got it. 4.24.
it.
Yeah?
Took me forever, but yeah.
Perfect. Okay. All right, example 4. On a, hopefully we won't be doing too many second derivatives. So that was kind of icky. On
I
a
think we need
Sunday,
a break.
a 50-foot flagpole, they have a picture, casts a shadow that changes with the angle of elevation of the sun. So the shadow is going to change depending on where the sun is located, right? If the sun is down here further, right, like it's rising in the sky, the shadow is going to be longer this direction. Do you see how that works?
Wait, if it's higher, it's longer?
If it's higher, it's shorter.
Okay.
The shadow will be longer if it's down here, right? You see how that works? Because that's the angle, okay? So that's how that's going to work. All right. Let S be the length of the shadow and theta be the angle of elevation of the sun. Find the rate at which the length of the shadow changes with respect to theta when blah, 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 blah. Okay, this is a very difficult problem. I don't expect you to be able to do this by yourself, but it's a good problem to do together. So here we go. Are you ready?
Semester finally.
Yes.
Oh, man.
First semester, not second.
Okay. We are talking about the length of the shadow. So we are wanting to represent this length of shadow. Got it?
Yes.
Okay.
Question.
So here is this angle, and this guy is consistently staying at 50 foot because that's how tall the flagpole is. So we need a way of relating this, going back to sine, cosine, and tangent, a way of relating angle theta to this side and to side S. This is a right triangle.
So
That's
that's
opposite.
Opposite
And adjacent.
and adjacent. So we have tangent, okay? So we're doing tangent
Tan
of what?
45.
Tangent of 40, no. We'll call it tangent of theta. We'll plug in 45 later after we take the derivative. We got to take the derivative yet.
Take the derivative.
Yep. Tangent of theta equals the opposite, which is 50, over my side S.
Theta.
Over my side S, okay? Or X, whatever you want to call it, okay?
Oh, I put 8.
All right. Okay, here, right here tells us what we're trying to find. Find the rate at which the length of the shadow is changing.
So
Okay.
Shadow.
So we need to solve this equation for shadow, right? We need to solve for shadow. The rate that the shadow changes. We need to solve for shadow. So if I'm trying to solve for shadow, I can bump those two, right? And say S is equal to 50 over tangent theta. Can I do that?
Yep.
Okay. We're solving for the rate of change, right? We know that derivative stands for like the instantaneous rate of change, right? Rate of change means derivative. So what I'm trying to do is I'm trying to find the derivative of this thing, and then I can plug in 45, and that will give me the rate at which the shadow is changing. Okay? We are wanting ds over dt, which is the derivative of shadow, right? That's another way of saying like y prime or f prime of x or ds dt is it's just with respect to time because we're dealing with
The sun's
the
movement.
sun changing over time. So feet, let's see, express your answer in feet per degree. Okay, so whatever. Don't get bogged down with the notation. We're just finding the derivative of this thing. How do I find the derivative of 50 over tangent theta? Quotient rule. F prime g minus g prime f all over g
Hey,
squared.
Kwame, I got a question.
Yes, dear.
So hypothetically, if we were to graph this and we use like the different positions of the sun, would it look like a parabola?
If we would graph the shadow or just graph the sun?
This shadow in correspondence with the changing of the sun's position. Would it look like because if the sun is over here, the shadow would be the same length as if it were in this.
Right, kind of.
like
It would
this way.
actually look like a function that looks like this. It would actually do one of these, which is the sine function. The graph of sine is a wave that looks like that. So that's what the shadow of the
But
thing
no,
looks like.
we're not dealing with sign.
Or cosine. Cosine also does a wave like that.
But I thought
Don't
we
worry
were-
about that. She's asking a weird
It's
question.
the same wave.
She's asking a weird question. Okay, so let's do
Yeah.
f prime. Oh, okay.
Yeah, my question
G
had
squared.
nothing to do with that.
Yeah,
so-
your question didn't have anything to do with that. Tangent squared is on the bottom. What's f prime?
Yeah, where it's
Nothing.
Yeah, what's f prime? What's the derivative of 50?
1 or 0?
Nothing.
What does nothing mean?
0.
0. The derivative of x is 1. So we don't even have to put g in there. Tangent x or tangent theta. He's going to be gone because he's times 0, okay? G prime, what's the derivative of tangent?
Secant squared.
Secant squared theta, and then times f, which is 50. Okay, let's simplify.
Wait, all
Blah.
over
Negative secant squared. Blah, blah,
square.
blah.
Negative secant squared theta, I'm going to go negative 50 secant squared theta. Can I do that?
Whatever.
All over tangent squared theta, technically.
So negative 50 secant squared
Okay?
theta all
Oh, there's so many
over-
things I could do, but you guys don't know how this works. Meh. 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 Do you want me to do it anyway?
No.
No?
Wait, like we won't understand or they won't.
Like you might. Like you guys maybe will understand this.
Probably.
It's gonna end up simplifying it to be really nice. Should we do it? Sure. Secant is 1 over sine squared, right? So if I'm doing this, this would be like negative 50 over cosine. No,
secant is-
cosine squared. Cosine squared. That's what he is, right?
Yeah.
That's what he would look like, okay? Tangent. Do you know what tangent is in terms of sine and cosine? Look at my sink and tank and whatever else. Tangent is
Sine over cosine.
sine squared theta over cosine squared theta. Got it?
Yeah. 'cause
That's what he is, right? So I'm writing everything in terms of sine and cosine. Got it? That's what tangent is. But you can keep flip flips. So we're gonna flip him to the top. So we have cosine squared theta over sine squared theta. And guess what happens?
Shoot.
We have negative 50 over sine squared theta, and all we have to do is plug in for sine.
Okay, give me a second. I gotta write all
Boo.
that down.
Yeah.
Okay? Did that make sense a little bit ish?
Yes, it did make sense.
Okay.
Negative
Okay.
50.
You know, it makes sense, but I'd definitely not be able to do that by myself.
It just makes it nicer so we only have one thing to plug into rather than like 2 things. And one of them we have to change to cosine anyway. To plug it into our calculator. Okay, you want me to go through it again?
Yes.
Okay, so we are to this point right here. Negative 50 secant squared theta over tangent squared. We said secant squared is 1 over cosine. So I'm going to leave the negative 50 over cosine. That's what secant squared is, okay? Tangent is sine squared over cosine. So I have this fraction over this fraction, like this guy over this guy, okay? But then we kept flipped him to the top, so now he has cosine squared over sine squared, right? But then the cosines cancel, so negative 50 over sine squared. And now we're going to plug in 45 degrees. We're going to plug in 45 degrees. We're plugging in 45 degrees. Which means we have to change to
Shoot.
degrees. We have to put our calculator in degrees. Is that what you were asking or no?
So negative 50 divided by sine squared theta.
Yep.
And then plug 45 in for that.
Yep, we're gonna plug 45 in for sine. Blah, 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 blah. Okay, so we need to put B in degrees. Negative 50 over sine of 45, that answer squared.
And
Okay,
all
we're gonna
in
take
radians, all in degrees.
all in degrees. All in
We
degrees.
have a negative feet per degree.
What?
Yeah, because
On mode.
you go negative,
The answer.
because you're going backwards. Backwards.
Second way.
Here, let me show you like this one.
So
This is
negative
the positive direction.
negative 50 over sine How do I square my sign? Before taking it times,
I got negative 100.
Yeah. I was gonna say.
And it says express your answer in units of feet per degree. So it is going negative 100 feet per degree. So for every degree that it goes up higher in the sky, it is coming closer, right? Because we said as the sun goes up higher in the sky, this shadow comes in closer, right?
So
Negative 100 feet per degree. So it's coming in 100 feet per degree, which is a lot, it seems like,
Okay.
per degree.
How tall is
If
50
it's
feet?
50 feet tall, then like.
I don't know, but I have to sneeze.
Now it's changing negative 150 feet per degree when it's at this point, when it's at a 45-degree angle in the sky. When it's going like, so from 45 degrees to 46 degrees, it's going 100 feet per degree, right? But if we were to plug in 46 degrees, it probably would be going like 90 feet per degree, right? As it goes higher up in the sky, the rate is going to slow down, right?
Yep.
So like as it's coming up, your shadow is getting really, really close, but as it goes, and then it's going to slow down.
Nothing there.
So it's not going to be changing at 100 feet per degree when it gets over top, and then it's going to speed up. It's like, we do an example like this in the old textbook. I should pull it back out again. But it's like, if you have like a cop car or something with a flashing light that goes around in a circle, and it's like put up against a wall, okay? And it's going around in a circle, and it's going like this, like the light is going like
the
this.
dot will get
It's-
closer to.
If you look at the wall, it'll go zoom, boom, all the way off, right? You see what I'm saying?
Yeah.
Okay, it's gonna like look like it's going really fast, and then as soon as it gets toward the wall, then it's gonna go zoom off really fast. Okay, so like that part where it's really, really close to the wall, it's gonna look like it slows down, but it doesn't. The light is still going the same speed. It's the same thing with a shadow. It looks like it's like the shadow is moving really fast until it gets to like right overhead, and then it's gonna look like it's not changing shadow very much, and then it's gonna like really change really fast. Does that make sense?
It is an actual.
But it's- yeah.
Same concept.
Yeah, the sun is still moving at the same. Yeah, the sun is still moving at the same rate, but the rate at which the shadow is changing is going to be different. Does that make sense? Because it's going to look like it's. Yeah.
The rate of the sun stays constant. The rate of the shadow is not.
The rate of the shadow changing is not just because of that.
Okay, can
Woo!
we pause here?
Look at that,
Is this a good spot to
man! Oh
pause?
man. Yeah. Where do we have one problem left? Yeah.
No,
I don't
True.
even think
I
we can do
remember
that one
those
problem.
stupid spring problems.
Yeah.
And those
We did a spring problem in trig last year, I think.
Yeah, we did.
Yeah, we did.
Yeah.
Yeah, we did.
Like hands-on or like in a textbook problem?
That's exactly what it looks like. Okay. Why don't you try? The homework for this is 2, 6, 8, 12, 24, 26, 40.
What page is it?
Try the
116?
first like 4 problems, because I'm guessing those are just like find the derivative, don't plug anything in.
Oh my gosh.
It's okay from there. Okay, try those first 4 problems. You should be able to do that. Oh, page 116. Try those first 4 problems.
Oh my heavens.
Oh my heavens. What? Yeah, I'm missing a 2-4 from you. Is that 2-4? Yeah. Okay.
Oh, Jack had it last.
You come back here when you have a chance.